Hello, this lesson is on the empirical rule. This relates back to standard deviation and distribution shapes. So it just kind of brings it all together. It'll be a very short lesson, which will be good, a very short video. It's one page if you have the lesson or the notes. So we'll just hop right in, and that way you can get the information as quickly as possible. All right, here we go. So this is what that looks like. The empirical rule is for data sets that are roughly bell or mound shaped, and that's the only time that the empirical rule applies. You might also hear this as symmetric, which relates back to that distribution shape video. We had right skewed, left skewed, and symmetric. So this is only for data sets that are roughly or approximately symmetrically shaped. The empirical rule is also known as the 68, 95, 99.7 rule. That might seem very odd to you. Why would we use those numbers? But you'll see in just a second why this makes sense. So this is a picture of maybe what would be considered mound-shaped or bell-shaped or symmetric. If you remember back to the histograms or the dot plots, and we kind of tracked the shape of them, they might have been right skewed, left skewed. This is symmetric. Approximately 68% of the data lies within one standard deviation above or below the mean. So you might see this, and it's saying that 68% of the data lies within one standard deviation above or below the mean. Remember, mean is X bar, sample mean. And then approximately 95% of the data lies within two standard deviations of the mean, and approximately 99.7% of the data, so almost all of it, lies within three standard deviations above or below the mean. And you can see that here, 3 standard deviations above or below, 2 standard deviations above or below. And I want you to take a second to label this graph here in a way that makes sense to you. You can pause it and do that if you want to. And when you come back, you'll see that the middle, the center, is X bar. And then this is X bar plus 1 standard deviation. This is X bar plus 2 standard deviations. X bar plus 3 standard deviations. And then on the other side of it, that's X bar minus 1 standard deviation because it's below the mean. X bar minus 2 standard deviations, X bar minus 3 standard deviations. We also know that this is 68% of the data, which means that 34% is here and 34% is here. So we're splitting it up. And we know that 95% of the data is within 2 standard deviations, either above or below. And we also know that, I'm gonna have to go out a little bit. Uh, 99.7% of the data is within 3 standard deviations above or below the mean. So there's that, and you could find these percentages by subtracting 95 from 68 and dividing by 2 to find those, but it's not super important. So we'll keep going. And then we have an example here. If a data set has a mean of 30, so X bar is 30, and a standard deviation of 5, then I want you to find approximately 68% of the data falls between which two numbers. And 95% of the data falls between which two specific numbers based on this information. So pause it, try to find those and come back and check your answers. Hopefully you found that if one standard deviation equals 5 units, we'll just call it units here, then one standard deviation below the mean would be 30 minus 5, and one standard deviation above the mean would be 30 plus 5. Then 95% represents 2 standard deviations, and 2 times 5, because one standard deviation is 5, is 10 units. So 10 units below the mean is 20, and 10 units above the mean is 40. And then 3 standard deviations is 3 times 5, which is 15. So if we go 3 standard deviations below the mean, and then 3 standard deviations above the mean, we end up with those ranges. That's all for today. I hope you enjoyed it. If you have any questions, please let me know, and I would be happy to help.